Hi, my name is Ivan KOZHIRUG, and today I'll be talking about technical excellence at scale. Well, first, thanks for joining this talk, and I'll start with a really brief introduction about myself, as I'm not one of the well-known speakers in our community. So, yeah, my combination of names is really unique. I guess not only in Bulgaria, but also probably worldwide. As my father is actually Polish, that's why my surname is not traditionally Bulgarian, and people usually uh, contact me in English on LinkedIn and so on. But otherwise, I've lived in Bulgaria my entire life, so I speak Bulgarian. Of course, this presentation will be in English. A little bit more about myself. Currently, I'm working at Tide. I started there in 2020. I'm working as a staff software engineer. And during my time at Tide, I actually witnessed our engineering organization growing from something like 35 backend engineers to more than 100 in just a year and a half. So I was able to witness the kind of policies that enable such a rapid growth without sacrificing technical excellence. Prior to joining Tide, I spent around 8 years in the gambling industry, and my interests include software architecture in general, microservices, event-driven systems, uh, DevOps, and cloud, and all kinds of stuff that most of the software engineers these days are interested in. So let's start with the actual talk. First, let's define what technical excellence actually is, because that's a term that doesn't have a kind of a concise or short definition that everyone knows. Different people or different organizations can have varying perceptions of this subject. So you don't usually just notice that someone is a good engineer, or that the company has strong engineering culture and they're kind of an example of technical excellence. But if you ask most of the people to define what technical excellence actually is, it's not that straightforward. So I even have the feeling that it might fall into the category of I know it when I see it. And if you Google this term, you'll find out that it was actually defined by a judge in the United States like 70 years ago, when basically the times were different, and certain movies were deemed immoral. So a judge had to decide if a movies should be um, allowed in cinemas or not. And the judge said, I don't have a proper definition for what's immoral or what not. So I know it when I see it. Well, in terms of technical excellence, you can find a lot of blog posts and even talks about this subject. For example, Martin Fowler has a nice talk in YouTube about technical excellence. And it turns out that even NASA published a paper titled Technical Excellence, a requirement for good engineering. And when it comes to NASA, it's probably one of the organizations that's most strongly associated with technical excellence, because everyone is aware that just the number of brilliant engineers, not just software engineers, but also mechanical and all types of engineers that work or have worked there during the past nearly 60 years, I guess. So they sent people to the moon 50 years ago. They are continuously sending vehicles to Mars and even out of our solar system. So basically, in this report, NASA defined four guiding principles for technical excellence. They include clearly documented policies and procedures, effective training and development, engineering excellence, and continuous communications. As you can see, engineering excellence is just one of these. There are other things that are really important for maintaining technical excellence on an organizational level, and we will discuss some of them in more detail later in the talk. But finally, let's try to define what technical excellence is. Just some really simple definition. So we can say that technical excellence means continuously learning, striving for quality, and being open for new ideas and willing to try out new approaches. So I think that the two most important things here are continuously learning and striving for quality. Quality is obviously important, but if you don't learn new things and just focus on quality, in the long run, you won't achieve technical excellence. And there are two aspects of technical excellence. Obviously, this is the personal commitment. Each one of us as engineers has to learn new things all the time, and of course, we should be dedicated to quality. But most of us don't just work as individual contributors somewhere. Most of us work in bigger companies or organizations, and we are constantly collaborating with tens, if not hundreds or thousands, other software engineers. So each software company or engineering organization needs to nurture the right environment and culture that supports learning and knowledge sharing. Without it, even if the organization has a lot of really strong engineers, they probably won't be able to maintain and achieve technical excellence. But since this talk is about technical excellence at scale, let's see why scale actually matters. So in order to do this, let's compare small and big organizations. If you work in a small company, like ones that have 5, 10, or 20 engineers, most probably you communicate with the other engineers on a daily basis. So in small companies, best practices and new ideas can be easily spread in an informal way. This means that you can just share your knowledge during casual chats in the office or during lunchtime. So, and due to the size of the company, this statement holds true even in today's world that's mostly remote. People are working, most of the people are working from home. Your colleagues might be located hundreds or even thousands of kilometers away from you. But even in that case, in small companies, most of the people are usually on the same Zoom calls or in the same Slack channels or whatever other means of communication they use. So again, this doesn't change the situation much. Spreading best practices and new ideas is really easier in smaller companies. And in a company with a smaller size, it's if you have even 1 or 2 engineers that are committed to technical excellence on a personal level, they can have a huge impact because usually they will strive to maintain quality. They'll learn new things and they'll share them with the other engineers. So it's much easier. You'll achieve technical excellence in a kind of in a natural way. But if we try comparing big companies, we'll find out that the situation there is quite more complex. So in big organizations, the impact of an individual is usually limited. So even the even brilliant engineers can't spread their influence to more than a few teams. So even if the company has a really strong brand and it's able to attract the brightest engineers from all over the world, and even if the company has a good talent density, which means that these strong engineers are equally distributed across the teams, that's still not enough for maintaining technical excellence at this scale. because different people, teams, and departments can have different views about this subject. And it might turn out that what seems good to one engineer or one team, it doesn't look like that for another one. So you need a company-wide agreement on what good looks like. And technical excellence is actually impossible without a commitment on an organizational level. Basically, making sure that this agreement really exists, and making sure that all the engineers are encouraged to learn and share things among themselves, and also ensuring consistency across the entire organization. And as we mentioned, small and big, it's actually worth saying that in today's world, transitioning from small to big can happen really quickly. We all know about a lot of successful startups that actually started with a really small team of engineers. And in order for a startup to become successful, most probably these engineers should be really strong. But as the startup grows and gets more funding, usually this funding is spent on actually hiring more and more engineers. And at some point, the initial members of the engineering team will be largely outnumbered by the new joiners. So no matter how brilliant they were, they still won't be enough to maintain technical excellence in the long run. So having the right policies early on is crucial for maintaining technical excellence as the organization grows. So even if your organization is currently small, but you want it to succeed and you're already seeing that it has potential to succeed, it's good to start thinking about these policies. And also, unfortunately, it's not uncommon to see successful small organizations that started with a really strong engineering culture, but that failed to maintain it as they grew, because the initial members of the engineering team will at some point leave. They'll want to look for new challenges, and if you don't have the right policies in order to onboard the new joiners, and so they can just strive to maintain technical excellence, then probably the engineering culture of your company will quickly deteriorate. And let's discuss the concept of tribal knowledge. So usually in small organizations, everything starts with tribal knowledge. So you have a few people that just know how things work, and everyone else is consulting with them, just asking them questions in an informal way. And the formal definition for tribal knowledge is that this is information that is known by certain individuals or groups of individuals, but it's not documented and is not common knowledge to everyone. This might work to a certain extent in a smaller company, and at the initial stages of a startup, you're just focused usually on surviving, on meeting the next milestone. So you just tribal knowledge is not your biggest issue. But as your organization grows, the people holding the tribal knowledge will have to handle more and more requests for help. So they'll start spending almost all of their time on blocking others. And at some point, as the organization continues to grow, they might not even have enough time to answer all the questions. So obviously, this is not scalable, because you'll have these people will kind of become like a bottleneck, because everyone will want to contact them and just get some help. And as I mentioned before, tribal knowledge will be lost when these people leave, and they won't be at your company forever. That's for sure. And now let's discuss another concept that's again related to technical excellence, and of course this is relates again to documenting the organization's knowledge. So first, we need a general shift in terms of in terms of documentation. So it shouldn't be something that is postponed or just thought of a second-class citizen. Uh, documenting knowledge should be an essential part of delivering software. And when it comes to tribal knowledge, the first step obviously is identifying the tribal knowledge holders and asking them to pinpoint the gaps in documented knowledge. Then, of course, these gaps can be filled. But the hardest part is actually making this shift left and start documenting things early on at the idea stage. Because leaving something for later actually might mean that it will just never be done. Okay, and what is actually the buzz factor? This is quite an interesting concept, and it is quite related to tribal knowledge. So a few years ago, I was working at a small company where we had just 4 backend engineers, and we had to maintain a really large system. So each of us had to take ownership of a portion of this system, but no one actually had enough knowledge about the other parts that were owned by someone else. So the CTO of the company used to ask back then, okay, what would happen if any of you gets hit by a tram? Probably because there were trams running down the street near our office. I hadn't heard the term buzz factor back then, but yeah, later on I realized that this was a really good example of the buzz factor. And so let's see what the buzz factor actually is. It's defined as the minimum number of team members that have to suddenly disappear from a project before it gets derailed due to lack of knowledge. And obviously, relying on tribal knowledge will produce low buzz factor numbers, even as low as 1. And when it comes to technical excellence, you definitely don't want to have a low buzz factor, because you don't have to rely just on a small number of people that can ensure that your organization follows the best practices, or that it can try out new ideas, innovate, and so on. So that's why tribal knowledge, as we discussed, it doesn't scale well, and maintaining technical excellence is important. So let's have a look at some approaches that can make sure that when it comes to technical excellence, you don't just depend on a few of your engineers. And first, let's start with architectural principles. They are something on a higher level, but they're quite similar to the principles that each of us has in our everyday lives. We all have a set of fundamental beliefs or core values, and they guide us when choosing between the right or wrong, or when we are faced with an important decision. And in the software engineering world, the vast majority of the important decisions are actually related to architecture. And why architectural decisions are so important? They are really important because they are made early on in the process, and changing course later is really expensive. So getting them right is crucial. No one wants to change the architecture of their system in the middle of the project. Sometimes it's inevitable. You have to do some refactorings, migrations, but it's better to get things right at the beginning if possible. And again, speaking about scale, big organizations usually produce and maintain large systems. It means that some subsystems that are actually parts of the larger system are maintained or owned by different teams in different departments. And if you don't have a common agreement on some architectural principles, it might turn out that the different teams and departments are creating architectural designs that are incompatible with one another. And so architectural principles actually help you define what good architecture looks like in your organization. Also, relying on documented principles allows comparing different design proposals without falling into personal preferences. So uh, you're able to choose between the proposals by just comparing their alignment with the principles instead of different people just arguing or sharing their preference or just personal beliefs. And what is a principle? A principle should be something really broad, really general. It should be general enough to apply to a broad class of problems. And for example, some of the principles that we have at Tide now are maximize cohesion, minimize coupling, promote simplicity, transparency. As you can see, these are really abstract statements. The first one, maximize cohesion, minimize coupling, probably everyone has heard early on their careers or even at university, because this principle doesn't apply only to software architecture. It also applies at a very low level, for example, to the relation between different methods in a really small computer program. So, of course, having principles and using them and applying them has its consequences. So let's take, again, for example, maximize cohesion, minimize coupling. In terms of software architecture, it means that you should prefer single team-owned services over shared monoliths. You should prefer a single-purpose services over monoliths, and you should prefer an event-driven over request-response model. Of course, there are other consequences. I'm just mentioning a few of them. But similar to the real world, the software engineering world is also quite complex. So some of your principles might overlap each other, or they might even contradict each other. So expect to just to have to choose between your principles. These are the so-called trade-offs. Sometimes these choices might be really hard. You might spend days thinking about them, but at the end of the day you decide, okay, it's better to follow that principle and not follow the other one, or just violate it in some way. And in some cases you might completely have to ignore some principle, but of course it's better to have a really good reason for doing this. And after we discussed architectural principles, which are something at a very high and abstract level, let's get a bit more on a lower level, and let's discuss the concept of guidelines. At some companies, these are known as standards or style guides. So what is a guideline? A guideline is a collection of best practices, rules, conventions, processes, and ways of working that's applicable only to a specific subject. Unlike architectural principles, guidelines shouldn't be general or applied to a broad class of problems. So they are focused on a specific subject, and we'll see some examples in a minute. The thing about guidelines is that they really promote consistency across the organization, and they just promote knowledge sharing and reduce the dependency on tribal knowledge. So instead of your engineers having to constantly consult a small set of experts for their tribal knowledge, they can just find the guideline for the specific subject, read the guideline, and just learn something new and start applying it in their everyday work. And let's see some examples of guidelines. For example, you can have a language-specific guideline like Java coding conventions or Python style guide. Or you can have a guideline for designing REST APIs, or a guideline for asynchronous messaging, or a guideline for using databases, or a guideline for code reviews. And in general, when deciding to create some guidelines, there are some subjects that are more important than others in terms of creating a guideline for them. First, the first candidates that you should consider are issues that arise frequently and people get stuck on. So if you observe that your engineers are struggling with certain with a certain pattern or certain library or certain approach, and they frequently need help with this, probably it's a good idea to to create a guideline, describe the common pitfalls, and describe the desired approach across your organization. Um, the other main candidate for creating a guideline for is actually the things that could be done in different ways by different people teams. So if you notice that some teams are using different libraries for the same thing with no apparent reason for it, or if they're using a different format, for example, for their REST API requests or response, or in their event-driven commands or events. So if you notice these inconsistencies and there is no good reason for being inconsistent, then it's a really good topic for a guideline. Just create a guideline that describes the common approach. But it's not a good idea to have, on the other hand, it's not a good idea to have too many guidelines. So avoid creating guidelines for things that everyone is familiar with, or almost everyone. Because keep in mind that people have a limited capacity for remembering things. And the more guidelines you have, the bigger the burden on your engineers will be, because when they every time they want to open a PR or just write some piece of code, they'll need to think about all the guidelines you have and if they are following all of them. And also think about the new joiners, because each new joiner has to read all the guidelines probably in the first days after they join. So if you have a large set of guidelines, this can be counterproductive and simply delay the onboarding process. And when it comes to rules that might become parts of a guideline, we can divide them into three types. The first is rules that prevent disasters. So here, think about, for example, having some guideline about security. So if the security of your software system is compromised, this can really have a disastrous effect on your company, because your users might get hacked. If you're in the financial area, for example, this could mean that your users directly lose their funds, or even if you're into some other business, it could still mean that the data of your user gets leaked. So these are really rules that every company probably should have, because they really prevent disasters. The second type of rules are the ones that enforce best practices. For example, you can think about rules that make sure that your code base is maintainable, or that you're producing reliable systems, and so on. So these aren't so critical, at least in the short term, because if your code is not maintainable, your users won't get hacked, or just the company will continue to exist. But in the long run, if the code base is not maintainable, you just won't be able to deliver new features or make changes to the existing ones with the velocity that you want, because we all know how hard it is to change code that's not written well and not maintainable, or in general if you have bad architecture and stuff. And the third type is actually rules for consistency. So these might seem not that important for some people, because they relate to things like format and naming conventions, which seem like, okay, whether does it matter what the format is, or that we have the same format across the organization. But we'll see in a minute that there is a really big benefit in maintaining consistency across the organization. And that's why even this type of rules is listed as third. I would say that it's nearly as important as the first one. And why is consistency so important? First, it enables internal open source. And what is internal open source? Internal open source actually means that engineers from another team, not the one originally owning a service, can easily can easily have a look at the code and just quickly understand it and even make changes or bug fixes there. Because if all your teams just have the same project structure, use the same set of libraries, use the same naming and formatting conventions and so on, it is very easy for engineers that are not originally from that team just to jump in and be able to understand the logic and make some changes. And that's really important if the team that owns a service is actually doesn't have the capacity currently, and they are just busy and can't accommodate an urgent change request or an urgent bug fix. Then just engineers from another team can easily jump in and do that. Of course, if the original team for some reason can't have don't have capacity to actually own the service, transferring ownership is really easy because um, at least in terms of understanding the project structure, libraries, and all the other conventions, because everything is similar across your organization. And of course, when it comes to consistency, there is a trade-off between consistency and freedom. Because when you limit the choice of libraries and tools, languages, uh, patterns, naming, and format conventions, some people might not be that happy initially because everyone has their preferences. Some people prefer some libraries or some tools, and different people just like different things. But in the long run, and especially the bigger your company is, consistency always wins over unrestricted freedom. Because imagine a company where each team just decides to use a different library for the same thing, then just your code base will become very hard to maintain at some point. And another benefit of consistency, especially when it comes to choices like format and naming conventions, is that it saves time that could otherwise be wasted in unproductive discussions. Because again, here it comes to personal preferences, and some people have really strong preferences. They like some passionate. They like to enter some passionate discussions about them. And when you have a guideline about the formats and about style and so on, everyone just has to follow the guideline. And these discussions are just eliminated because that choice has already been made a long time ago. And and yeah, I'm not saying that the discussions are something bad. Of course, discussions and just communication is very important. But when you eliminate these discussions about such low level things that can be addressed by consistency guidelines, you actually free a lot more time for your engineers so they can engage in higher level discussions about architecture and just the more important things. And of course, having having some guidelines means that someone has to enforce these guidelines. So in the code reviews or pull requests, engineers should check the code if it actually follows the guidelines. But some of the guidelines might be quite boring, like checking for a format convention or naming convention. And uh, and this really, first, it would take the engineers quite a lot of time. It's boring, and people are not machines. They will not catch all the cases. They will miss some of them. And this checking for things like format and naming is actually something that automated tools can do much better than humans. And they not only do it better by catching all the cases, uh, they also do it much faster. So it saves a lot of time and it helps you scale. So guideline automation will help you scale in the long run, and it will prevent your engineers from just having to look at boring things. And another important benefit when it comes to consistency is actually that if your code base is consistent, it is much easier to run or create your own automated tools. For example, if you want to enforce some of your guidelines, you might want to use a static code analysis tool. And then if your code base is not consistent, you have to just handle all the different corner cases and just exceptions of the original rule. And the same applies, of course, if you need to create your own tool, then you'll need to handle those corner cases as well. But today there are a lot of tools that you can just buy or just use out of the box. But if you don't if you don't find one for your specific guideline, you can always create your own. And again, automated guidelines really helps, and especially if you run your guideline, if you run these checkers as part of your CI/CD pipelines, this ensures that your guidelines are always enforced. And a final slide about guidelines. So how to manage them. So anyone should be able to propose a new guideline, but whether it gets adopted actually depends on the engineering community. Of course, achieving 100% consensus is not an option, especially in bigger companies. But a simple majority is usually fine. And each guideline needs an owner or a group of experts that can be defined as owners or gatekeepers of the guideline. And these should be people that are really respected as experts on that particular subject by the entire community. And these people should have the power to approve or decline proposed changes to a guideline. And of course, your guidelines are not set in stone because, for example, new versions of languages will be released or new versions of libraries that will make your old guideline obsolete. You can always deprecate a guideline and create a new version for it. Or you can even, if you see that a certain guideline actually becomes a burden for your engineers, that it creates more problems than it solves, you can always just completely scrape that guideline. But as with most things, it's a really good idea to be data driven with decisions about your guidelines. So just try to collect some data about the way they are affecting your engineers' work. And after we discussed architectural principles and guidelines, things that are really broad and general and that apply to the entire organization, let's discuss documentation in general. Because apart from architectural principles and guidelines, your engineers usually need to create more documentation, like, for example, describing how a certain feature works or how a service works. So let's see some good practices about creating documentation in general. So from my perspective, the three most important properties of good documentation are that it's organized, easily searchable, and kept up to date. Fortunately, today we have a lot of options when it comes to tools that we can use for creating and storing documentation, and most of them come with really good search capabilities. But when it comes to organizing and keeping documentation up to date, then we again depend on humans, and people forget to do things, they get sloppy, they have other priorities, just the next deadline knocking at the door, and so on. And similarly as with guidelines, it's a good idea to automate documentation creation. We are all familiar with tools like Swagger for documenting REST APIs. You can use async APIs for documenting events and commands if you're using an event-driven architecture. But of course, there will always be things where just some engineer needs to write some documentation, just describing how things work or just describing some decisions. So let's have a look at some best practices. Of course, when creating documentation, it's a really good advice to always think about your readers, and keep in mind that the readers will actually be reading your documentation in 6 months, in a year, or in 2 years. So when writing documentation, just try to look from their perspective and what they might not know that you currently know, or what how things might change and so on. Because these people, these future readers, most probably they will have a lot less context than you. And also these people might have joined the company just even after you have already left the company. So what I have observed is that when creating documentation, most people are actually trying to answer the what and how questions. But those are usually available in the code. So every decent engineer can just uh, open a a certain project, a service, have a look there and understand what's going on and how things are implemented. But most documentation actually doesn't answer the most important question, the why certain decisions were made. Because so some decisions are just not obvious. People are not future readers of the code will not be aware of the full context. They won't be aware of the constraints that existed when the code was originally written. So creating documentation that explains the why is really valuable. And something that again I often observed and that I used to call the brave new joiners paradox is actually a situation where a new joiner comes to a company or team and they just have a look at some really old legacy code and they start saying, oh, why is this implemented like that, or it doesn't make any sense, let's change it, or let's even remove it, I don't understand why this is here. And they might even start questioning the the engineering, just the qualities of the engineers that originally wrote that code. They say, oh, I mean, a decent engineer won't write such piece of code and so on. But usually these people, they are not aware of the constraints and limitations that existed when the certain solution was developed, because the original creators might have been faced with really tight deadlines, or they might just be have been limited uh, by by certain libraries or tools, and they just didn't have another choice at that point of time. And this is a really good example of the Chesterton's fence principle, which basically states do not remove a fence until you know why it was put up in the first place. So if I need to translate this to software engineering terms, this means that you shouldn't change a design or a solution until you understand why it was designed in the first place. So as in this picture, something might seem like a fence in the middle of a field, but most probably at some point of time there was a good enough reason to put up that fence. And when it comes to documenting the why, of course, you can document the why behind every minor decision when creating software, but it's important to document the why behind the most important decisions. And as we already discussed, these are usually the architectural decisions. And there is this concept called lightweight architectural decision records that was defined more than 10 years ago in a blog post by Michael Nygaard. So it's just a sequence of files. Each of them is numbered and it has a title, a date, a status, whether the decision is accepted or pending, and so on. And it has a context. Basically, the context explains the why behind the decision. It describes the constraints that existed when the decision had been made. It describes the any limitations and so on. Basically, all the forces at play that existed at the time of the decision. Of course, the decision describes the decision, and the consequences just describe the consequence of the decision. What would happen after applying the decision? So when you have and after a decision is accepted, that file can't change. So when you replay the files starting from number 1 to the last one, you should just reach the current state of your architecture. Imagine like something like replaying events in event sourcing, something like that. And we talked about the benefits of good quality documentation, but just having some beliefs about this or some internal feeling is not the same as having some solid data that proves the benefits of good quality documentation. And in the latest Accelerate State of DevOps report that was published a few months ago in the autumn of 2021, for the first time, the benefits of documentation were actually analyzed. So the survey collected data about documentation for the first time. For those of you that are not familiar, this survey is run by the DevOps Research and Assessment, or also known as DORA team at Google Cloud. And it was conducted by contacting around 32,000 participants. So it's a really big survey, and the data is analyzed by using strong, really solid scientific statistical methods. So I won't just quote all the numbers here, but the survey proves that if teams with quality documentation are much more likely to have better software delivery, to implement security practices, and just fully leverage the cloud. And it also outlines a few best practices for improving documentation quality, like defining owners for the different parts of documentation. That's something quite obvious. Like with everything in life, if something doesn't have a dedicated owner, it just won't move forward. Or it either won't move forward, or different people will try to move it in different directions. The other suggestion is define guidelines for creating and maintaining documentation. At Tide, we even have a guideline called Guideline for Guidelines. Because writing quality documentation is not much different than writing quality code. You need to have some best practices and consistency when doing so. So yeah, having a guideline for creating documentation ensures both that best practices are followed and that your documentation is consistent across your organization. And as we already mentioned, include documentation as part of the software development process. This means this is actually this shift left, that it shouldn't be left as something that's not important and that can be done afterwards. And finally, let's discuss the concept of the so-called communities of practice. Why are they important? How do they help technical excellence at scale? So in today's world, most software engineers are actually faced with tight deadlines all the time. The new demands from business are coming constantly. And so a lot of engineers, they spend their workday just doing their normal work, and some of them even have to overwork. So they just work doing the things in the exact same way they've done it 3 months ago or 3 years ago, and using the exact same tools and technologies. And this obviously doesn't align well with technical excellence. Ben Northrop defined these concepts of more, extra, and nothing in his blog post titled "Always Do Extra." So when an engineer has 3 options how to spend their time after they are done with their normal work, they can either do nothing, basically just watch some YouTube videos or just have some rest or something, or they can just do more of their normal work, which is just continue grinding and just helping the company meet the deadline or just meet the next business demand, or they can do something extra, which actually means learning something new, experimenting with some new technology, and so on. And community of practice actually help a lot with enabling your engineers to do extra. So let's briefly have a look at them. Communities of practice, or COPs, are also known as interest groups at some companies, and these are basically engineers that share some common curiosity or interest in a particular topic. And COPs give people the opportunity to spend some of their working hours on things they are passionate about and that don't feel like work for them. And over time, COPs will usually nurture a group of experts on the particular topic. So the other engineers from, if you have a COP about databases, for example, the other engineers from the company will usually ask the members of the database COP when they are faced with a challenging database problem. And of course, the organization should encourage the members of the COPs to share knowledge with the wider community. And of course, a COP can't exist just on its own. It should be aligned with the organization's goals. It doesn't make sense to have a COP that's focused on technology or an idea that is not relevant to your organization, or at least in the foreseeable future. So by aligning the COPs with the organization's goal, you make sure that not only your engineers are becoming better, they are happier because they work on things that don't feel like work, but they can also produce something useful for the company, like creating some library that can be used across the organization, or creating a new guideline, or just something that can be of a real use for the organization. And let's have a look at the so-called hackathons or innovation days. This complements COPs in a natural way, because otherwise members of the COPs just need to find some time, an hour or two here and there, to work on their COPs. But if you dedicate a few days for hackathons, just every quarter or every month, 1 or 2 days, then your engineers will have days that are entirely dedicated to COPs, and they can spend working on something interesting without any other distractions from normal work, meetings, and etc. Of course, innovation days shouldn't be limited to just COPs. They can be a place where all kinds of exploration and experimentation can happen, and these are important prerequisites for technical excellence. Well, that was all from me. Sorry for going a bit over time, and thank you for your attention. If you have any questions, please go ahead. Yeah, so I see a few questions. I tried to have a look at the chat. So yeah, if you can automate a guideline, this definitely decreases the burden on engineers. So yeah, then having a large set of guidelines shouldn't be an issue. And in terms of if the guidelines should be across teams or across the whole company, it's really important that the guidelines are just across the entire company, unless it's something very specific for a particular team. For example, this team is using a technology that no one else is actually using, because as I mentioned, consistency is one of the most important benefits of having standards or guidelines. So you want your code base to be consistent, and your engineers to be able to understand code from other teams and so on. And in terms of sharing guidelines across the industry, I think that Google, for example, is doing something like this. I think their Java coding convention is publicly available. And so some companies are doing this, and if a guideline is general enough, I don't see a reason why a company shouldn't share it. Okay, I think that I answered most of the questions. Yeah, so if there isn't anything else, thank you again for your time and your attention, and see you in the next talks. Bye bye.